Hey guys, today we'll be solving a problem called lexicographical numbers. It says given an integer n, return all the numbers in the range of 1 to n inclusive, sorted in lexicographical order. So lexicographical order is the same order that you guys see in a dictionary, and for numbers it would be the smallest number comes first, and if this first number is same, go to the second number, and 0 is lesser than 1, similarly for 1 and 2. And for 13, all the 2, 3, 4, and 5 are at the end, because they have one uh, in the beginning, so obviously. uh, so the easiest method that comes to my mind is that I can stringify all of these numbers and sort them, because string sort internally has the same lexicographical sorting. But here there's a catch. They want us to write an algorithm that runs in big of n time, and sorting at the best efficiency would be n log n, and collections.sort in Java also uses merge sort, which is again n log n. So but I'll still give it a try, because to just show you what I'm meaning to say here, let's say I call this nums. This is a new array list that I have created here. I'll start my things at 1, go till n, and I keep incrementing. And here it should be inclusive. What I'll do is string dot value of uh, and I'll do nums dot add. This is certainly going to take care of converting my string, uh, my integer to string. So once I've added this, what the very simple thing that I need to do here is collections dot sort, and I can supply nums. The problem is I have to give it back in the list of integers, so I would have to cast this as either I'll just map everything. So let's say integer parse parse int and collections collect collections, that is to list. Oh, sorry, it's collectors of to list. Yeah, this should work. Let's just try to run. I'm pretty sure it would fail for some of the cases, since they explicitly want us. Okay, I'm missing the term. They explicitly want us to run in big of n time and use big of 1. Yeah, it passes the sample test case, of course. But let's submit. I'm pretty sure it'll say time limit exceeded for a few. Oh wow, it kind of worked, but we are really bad on time, because we are just faster than 18% of the submissions for Java. So let's just do one thing. Let's try to optimize this. So if I go to, so yeah, it says surprising. So let's just try to optimize this. If I start printing all the numbers starting from 1, and okay, here's a good catch. So any number starts from 1, we'll have to multiply it by 10, and maybe let's say the input here is 1000 to 234. What we'll do is, this is the order, and then we start incrementing 1 in the least important bit of the number, and this goes all the way to 1009. And now what we have to do is, we need to start incrementing the second digit. uh, okay, yeah, here's a pattern. Now we go all the way to 9. Now the previous digit was 1, so now we need to make it 2. Oh yeah, here's a pattern, here's a catch. Again, all the way. But the problem is, once we reach this stage, Okay, again, just notice the pattern for this one as well. Once you figure out there's a 9 and the previous digit is 9 as well, you go to one previous one. So here there are a lot of numbers. You print 1100 and then you start the same the logic that we sort of did here. Start with the lowest precedence number, check if it's 9 or not, and just if it's 9, just go to the previous one, increment, and make this one 0. Yep, this should work. So let's sort it out. So the best thing about this is this would require just one iteration. So I start at 0. I don't know why I removed that for loop, and we'll go to n. So here I don't need to increment, I don't need to start at 1 and end at n. I can end at n minus 1 because I'll still be printing n digits. Here I'll also have to keep a number to print. I'll start from 1. I'll just copy this because there's no autocomplete. And so if number to complete, number to print is less than or equal to n, we should print it. Or no, let's just not print it because we need to return it in the list of integers. Let's just call it nums and new array list. And once we are done with this, so what we'll do is we'll do nums.add and so once we've added the number to our, sort of the list that we are maintaining, what we need to do is we need to increment it. Sort of this would run for every line of code, and what we need to every for loop I mean. Now what we need to do is we need to check if the number, okay, this is number to add can we multiply it by 10? Yes, this, okay, we need not check if it's less than equal to 10 because less than equal to n. I think it will be a problem. Let's just not add this condition here because we need to handle a lot of conditions here. So let's say we add it and multiply it by 10 less than equal to n. What we do is numbers to add is multiply equal to 10. So now we've sort of incremented the value by 10, and we, of course, it can also be you know less than that number. That is anyway going to get sorted because as we keep moving forward. But in case it is not, we also need to add that condition that for ones and twos and all of those numbers. So sort of can we add another if here? We need to check for those numbers as well. So if number to add is, so now we've already multiplied by 10. So the next for loop that it comes to, so let's say if we've arrived to 1000, we do not want to go to 10,000 but want to come at 1001 because 10,000 is out of what we've started with. For reference, this is n. So we need to eliminate this. So that elimination will already be done here. We'll come to else loop, we'll come to +1, and again this is less than n. If yes, I just don't need it here. Nums.add. Yep, I'm good. And in case, oh, one thing, this cannot be sort of this, okay, I do not need to add here because I'm adding a generic in a for loop. So what I can do is I can just do a plus plus. And the thing that I need to do here is I need to check and if the digit is not 9, because the moment I start adding a ninth digit, I would need to have an explicit handling. The same thing that I told you here. We need to be shifting, we need to be making it 0 and we need to increment the previous one. So what we need to do here is uh, sort of if number percent 9 equal to 9, if okay, my bad. And else for this else block, what we need to keep doing is I'll have to have a multi-line statement here. So I just keep omitting that number to add. I just keep dividing it by 10 until unless I reach a digit that is not 9 in itself. What I'll do is number to add divide by 10. Uh, yep, and sort of take a this. I just get a remainder, and if this is equal to 9, then so this is sort of complex. So so while the number to add divided by 10, in this case it was 119. 119, the last digit is 9. We sort of have to drop 9 and need to have an explicit handling here, because now we need to start moving the other way around. So to move one bit, what we do is we have number to add. We we just divide it by 10. That is a very easy operation there. And now, since we kept on removing one digit at a time, now we just need to finally update the number, which would be now the number itself divided by 10. Uh, and since we were doing a increment here itself, here also we need to do an increment. We just divide and yeah, this will get added all over again. So now we just need to sort of figure out the return statement. We return. Let's try to run this with at least a sample test case. It's wrong. Oh, all right. Oh, wonderful. It worked. Let's see if we are better in the runtime. Boom. You see the difference n log n versus big of n. Our code, which was 18% more efficient than the rest of the Java submissions, is now almost 61%. So quite happy with it. So do let me know in case you face any problems, and I'll definitely love to take it up in comments. Just drop in a comment how you like this video, or if you want me to focus on smaller nuances. I see that there is a lot of some bit of logic here. Just in case you feel you're stuck, just do drop in a message on my Instagram or my Twitter. I'm quite active there as well. Thank you so much, guys, for watching this.